Hi everybody, this will be the first lesson of Algebra 1. It might seem a little surprising that we're starting Algebra 1 on page 72, which is chapter 2.2, but the reason we're doing that is because the topic of this chapter, which is called addition of real numbers, is really primarily about adding negative numbers, like this right here, negative 3 plus positive 5 plus negative 6. This skill, the ability to add negatives, is one of the biggest challenges for most Algebra 1 students. Year in and year out I see this. So what I'd like you to do is plan to revisit this lesson several times during the course of the year. Come back again and again just to make sure that you have it straight. If you have your foundation in place and solid, the things that we can build on top of it will stay upright. So, I'm going to show you three different ways, first, second, and third over the course of this lesson, three different ways to add negatives. The first two ways are going to come straight out of the textbook. The third way is a modification that I'd also like you to think about. It might be the better way for you. Now, I don't care which of these three ways you choose. In the end, you've got to pick the one that works best for you. In fact, let me say that again. Your job is to pick the best way for you to add negatives. Once you do that, I want you to practice it until you have this skill mastered. Okay, so let's look at that first way. Come straight out of the textbook, page 72. The first example they give on page 72 is this one, A, negative 2 plus 5. And the way this first way works, they suggest that you think about whenever you have to add negatives and positives together, either draw or think of a number line and start your pencil on that number line where that first number happens, where it first appears. So that's at negative 2. So I'm going to put my pencil at negative 2. Then from there, as you add, you move to the right when you're adding positives, to the left when you're adding negatives. Okay, so I'm at negative 2. I add a positive, so I'm moving to the right 5 spaces. 1, 2, 3, 4, 5. I end it at positive 3. And sure enough, negative 2 plus 5 is equal to 3. Let's look at a couple more examples. Same idea, 2 plus negative 6. All right, this time I'm going to start my pencil at positive 2 over here, but I'm adding negative 6. So like I said, I'm going to move to the left. So I start at 2, 1, 2, 3, 4, 5, 6 spaces left from there, and I end up at negative 4. Just like it says here, end at negative 4. And that is the correct answer. 2 plus negative 6 is negative 4. All right, one last example here. A little more complicated because now we're looking at combining three different numbers, negative 3 and 5 and negative 6. But the same story. I'm going to put my pencil first at negative 3. So that's right here. Then I'm going to move to the right 5 spaces. 1, 2, 3, 4, 5. Then, like it shows over here, from this spot now, I'm going to move to the left 6 spaces. 1, 2, 3, 4, 5, 6. And after all that moving around, I end up at negative 4. Like it says here, you end at negative 4. And that's the right answer. Negative 3 plus 5 plus negative 6 is negative 4. Okay, that's that first way. And if this way works for you, wonderful. You can use it from now on. Any of these three ways is going to work. But if you don't like drawing number lines, or you find this confusing, there's a second way. Also right out of the textbook. This time it's on page 71. And the idea behind the second way is that negative numbers and positive numbers can be thought of like points or coins in some kind of game. So the way that the textbook shows the negative numbers is it draws these red symbols, one for every negative. So I've got 8 of these negatives. And for the positives, like this 3 here, it draws yellow symbols. So I've got 3 of these. And the next step is to match these up. So what I suggest that you do is you take the smaller pile, in this case there are only 3 of the yellows, and move it over so that it matches up with the bigger pile. And that's what they do in the textbook. they've moved these yellows over, and they cancel out the ones that are matched. What's left over here, the ones that couldn't be canceled because there weren't enough yellows to cancel them out, that's the answer. So like this shows, -8 plus 3 is -5. What I'm left over here with is 5 negatives. Let's try a more challenging question than this just to make sure this works. Now I've got 3 different sets of numbers to combine, -3 and 5 and -6. So here I've got 3 of the negatives. Over here I've got another 6 of the negatives. And in the middle, just like in the problem, I've got 5 positives. Like before, the way I'm going to do this is I'm going to match things up. So I'm actually, since I can do this on a computer, I'm going to drag these over. And then I'm going to cancel. Gone, one at a time, until what I'm left with is that one and those 3. So I've got 4 negatives. And sure enough, the answer is -4. So that's the second way. And that can work and will work for you throughout the year if you want to take that approach. Let's say, though, that you don't really like drawing number lines and you don't really want to have to draw these coins, these point symbols all the time. Let's say it's larger numbers like -17 plus 34 minus 96. Well, that's a lot of drawing to do, and that's a very long number line to draw. But you can still solve the problem. I find a third way, personally, for me, works better. Now, the way that the third way works is it really combines the basic ideas. I'm just going to go back for a second to this second way. It combines this idea of moving pieces and matching them up together with a very important property of addition. It's called the commutative property, and it's also in your textbook. And the commutative property is mathematician's language. And speaking of mathematician's language, here's more of it. The commutative property says that the order in which 2 numbers are added doesn't change the sum. Okay, so what does that mean in normal language for everyday talk? A plus B, it means, is the same thing as B plus A. Doesn't matter which number you start with. So whether you start with A or with B, doesn't matter. If you add them, you're going to end up with the same result. So for example, and this is the example they give, whether you start with 3 or whether you start with -2, if you combine the same things, then they're going to end up being the same answer. Now this only is true, and I don't know that the textbook gets this point across well enough, but this is only true. I hope this comes across as a highlight. You know what, maybe it doesn't. I think it might actually block it out for you. Let me use blue instead. It's only true because everything that you're doing is adding. If you were doing anything mixed in with the adding, multiplying as an example, it would change the rules and you wouldn't be able to move things around. But this, well, before I show you another example of it, let me point out something. You've known this about the commutative property. You might not have called it this, but you've known this since you were a little kid. You've known since you were little that if you had 3/4 and you added 1 more, you would have $1. But you've also known that it didn't matter which you started with. So if you started with the 1/4 and added 3 more quarters, still you'd have $1. So it doesn't matter the order. So this basic idea, it may have a mathematician's name, commutative property, but it's talking about something you've always known. Okay, so like I said, the third way combines the second way with this commutative property idea. This commutative property idea just has us moving things over. So let's look at it with actual numbers. -3 plus 5 plus -6. I don't want to have to draw a number line anymore. I don't want to have to draw little coins anymore. I just want to be able to move numbers. And that's what the third way does. My preference, personally, is to move positive numbers out in the front of the list. So I'm going to move 5 out front. And it's going to become 5 plus -3 plus -6, like it shows here. But there's something very important that I have to make sure I say very clearly here. Notice that I've put these parens around -3. If you're going to use the third way, then you have to put parens at least around the negative numbers as you move them around. That way you'll remember to keep the negative together with the 3 if you move it. And you'll remember you can't put the 5 in here inside this and make it -5 by mistake. You've got to move the 5 out in front of the whole thing. Get rid of that idea. Okay, so I've got 5 plus -3 plus -6. Now that I've got the positives on the left and the negatives on the right, I think it's a lot easier to combine. I'll put those -3 and -6 together, and I'll have -9. So what I have here is that same 5 minus the 9. Well, 5 minus 9 is -4. And that's the answer to this question. Let's make it even a little more challenging. Let's have a larger string of numbers. None of these are bigger than 10 or smaller than -10, but still, this is more complicated than we've tried with either the first or the second way. I'm going to start using some color coding here. I don't have a good yellow pen, so I'll use green for my positives. I know the textbook used yellow, but I'm going to move all of my positives together and move them over here to the front. So what I'll have is 5 plus 7 plus 2, and then I'm going to switch to red, plus, and here are my reds, -3, -6, and, sorry about the clumsy writing here, this is the technology that I have available, plus -1. Okay, good. Now I'm going to put, like I said, all the negatives together, and separately I'm going to put all the positives together. Okay, 5 plus 7 plus 2, it might not come immediately to you, but 5 plus 7 plus 2 is 14. And -3 and -6 and -1 is -10. So what do I have here? Well, I've got 14 minus 10. That's 4. And that's my answer to this string of numbers that I had to combine. Okay, so that's the third way. Okay, so your homework. 9 problems. I know it starts with number 10. Don't let that confuse you. I've taken this out of a book where I've skipped the first 9 problems. I just want you to tell me what the answers to these 9 questions are. Like I say here, use whichever of the 3 ways works best for you. Again, I don't care which of them you use because all 3 will work. But your homework for tomorrow, and I'll be looking to make sure that you have this answered out, is the answers to these 9 questions. And I need to see your work. When I say answered out, what I meant to say is worked out. I need to see your work for these. Your homework is not just the answers. Your homework is to show me the work for all 9 of these. So if you just give me numbers, like you say that the answer to number 8 is 14, well, that's not good enough. I want to know how you got 14. Again, the 3 techniques here are all part of the very first lesson of this class, and it's all about building that foundation for the rest of the year. If you get this down solidly, and you might have to come back to this a few times during the course of the year, but if you get this skill down solidly, then you'll have a good foundation in place.